Hi guys, Matt from ESU, and today I'd like to kind of dive a little bit deeper into the physical output configuration. The last time we spoke about this, I kind of went over what each output does. I described a little bit about front light 1, front light 2, what the difference is between that and just the regular auxiliary outputs. I want to dive a little bit deeper into that today and show you some other things that we just didn't discuss last time. So there are multiple strobing or flashing lights, and we want to discuss a little bit about how to adjust those because we didn't touch on it at all before, and it's pretty important. We have a whole section of the LokProgrammer that deals with that. So if we were to pick one of the lights that does have a strobing or on-off effect, if we go down to function settings, the tab right below function outputs, we can see that we have general physical output settings. And under there, we have a number of different features that we can adjust those flashing lights, or just the lights as a whole. So each one's, it's pretty self-explanatory. The frequency for blinking lights is just simply how often they're going to blink. So as of right now, by default, it's set to 1.95 seconds. So the light's going to come on and go back off, and then 1.95 seconds, it's going to come on again and go off. So it takes that amount of time to go from its off state to its on state, and its on state to its off state. And you can, of course, adjust that to however you like, depending on whatever it is that you're creating. So I guess it's about 2 seconds. So let's change it back just to keep things steady. So and each click goes about a tenth of a second there. So if we go to the next one, we are at grade crossing hold time. So this is how long the feature, whatever it might be, and oftentimes because of the grade crossing feature, we think of it as ditch lights, but it could be a beacon or a strobe light or something like that as well. This is how long that the ditch lights will flash random or back and forth alternately from left to right after the horn has stopped blowing. So once you've stopped pressing F2, which has grade crossing mode on, the horn will stop, but the grade crossing mode will continue to ring the bell usually and flash the ditch lights for, in this case, up to 5.24 seconds. And again, totally adjustable. And say I've got I'm trying to match a video of a locomotive. I just did this the other day to try to match Amtrak ACL 42s. Their lights are not normal ditch lights that kind of fade on and off. They're very abrupt on and off. So the first thing I did was find the ditch light settings, left and right. And instead of ditch light type 1 and type 2, I set these to flashlight because this would flash the light on and flash the light off, whereas ditch light would fade them on and fade them off. So I set each one to a flashlight, and I made sure, because in ditch lights, one of them has to be alternate phase from the other. So I had to check to make sure that they were, and they are set that way. And I need to make sure that grade crossing is on, because if grade crossing is not on, then I can't control them with the horn. So the ditch lights in this case operate with the horn. So I need to have that physical output controlled by the grade crossing logic. And if we go back to function mapping on F2, you'll notice the grade crossing logic is on. So I need to turn on my horn. It'll trigger the grade crossing logic, which flashes my ditch lights because they are activated by the grade crossing logic. Now I can still turn them on and off with F6, but this doesn't flash them, this just turns them on. The flashing effect is done with the grade crossing logic when the horn is blown. So off on that tangent just a little bit. Going back to what we were doing, we changed this to a flashlight, and so this would flash these ditch lights back and forth on the ACL 42s, and when I look at the function settings, I could watch a video and adjust if they needed to be a little bit faster, if they needed to be a little slower, and if I recall correctly, I needed to have those about 1.15 seconds in order to match the video. So from one side to the other, one light would go out, the other one would come on, and every 1.15 seconds they would switch. And that matched the video that I had very closely on and off. Now, I also paid attention to how long it took to turn the ditch lights off after the horn stopped blowing, and I adjusted that to about the same thing. I don't recall off the top of my head. Let's just say it was about 4 seconds, so that's where I would do that. So the fade-in time of the lighting effects, so say I have a headlight that has a fade-in and fade-out effect. So if we go back to my function outputs, I look at my headlight, notice that it's a dimmable headlight, which means that the dimmer logic feature, same as the what we were just talking about there, the grade crossing feature, the dimmer logic is active on the headlight, because if I use the dimmer logic feature in my function mapping, I want it to control this particular output. So if I look at F12, which is usually the dimmer in ESU decoders, the dimmer is on, but it's not actually talking to any output, because when the dimmer is on, any output that is controlled by the dimmer will be affected by it automatically. So I have the front light on as F0. This will turn it on and off. The dimmer logic feature will fade it in and out. But the fade in time of the lights is how quickly it will fade on, and the fade out time is how quickly it will fade out. And that can be different if you'd like with the ESU decoders. So lots of features there. The logical function dimmer will reduce brightness to, and this is pretty self-explanatory. So we just talked about the logical function feature of the dimmer. So if I want to dim my headlight, right now it's set to 50% of full brightness. Now, that may not be enough. It might be too much. It depends on, again, the bulb that you're using, or if it's an LED. Sometimes LEDs need to be dimmed down a little bit further to get by the resistance that's built into the decoder. So maybe we want to take this down to about 25%. And that would get us to the range that we'd like to be at, so that it's noticeable. Sometimes it's not noticeable at 50 or anywhere above. It's just going to depend on the situation. But that's what that's for. Logical function dimmer will reduce to the brightness when it's activated. So if I press F12, it's going to dim the headlight, and it's going to dim it to 25% of the brightness that it's at when it's on full. So and remember, each physical output, you can adjust the full brightness of that as a whole. So say I have this set to, about halfway. That would be 15 out of the 30, or 31. So 15 as close as I can get to halfway. So now that's my top brightness of the output. Then if I go to its 25% of that brightness, it's 25% of 15 now. So just keep that in mind when you're setting this, that it's cumulative here as well. Enforced slave communication, this isn't something that we're normally going to use. ESU made a locomotive a while back using, at the time, a V4 decoder, and now with the V5 we needed to add a feature to control that. So most users will never use this feature. Don't worry about this. But that's what I wanted to talk about today, was just how do you affect the frequency, the hold time, the lighting fade in and out, and that logical function dimmer brightness. So I hope that I've been clear. If you have any questions, again, don't ever hesitate to contact us at support@LokSound.com. Enjoy your new lighting features. Take care. Bye-bye.